Hi, and welcome to the 10th and almost last day of Keysight University Live. I'm Daniel Bogdanoff, live from Colorado Springs, and I'm your host for this event. Thank you for joining us. Each event day, we have an interview with a technical expert. Today, we get to sit down with Jason Lackey, who's part of our Ixia team. We've focused a lot on physical layer testing, but over the last year or two, I've been fortunate enough to get to branch out into some of the higher layers, and that knowledge has been surprisingly useful and given me new perspective on the tech around me. So I thought today we'd bring in Jason Lackey to talk about more about what happens as we get higher up in the stack, and we also talk FPGAs a bit. After that, we have a couple more snippets, and then we'll draw today's winners. Then we'll do some live Q&A just like every day, so put your questions in chat now. Let's jump right into that interview. We're joined today by Jason Lackey, and Jason originally came to us from the Ixia group, but he's been my go-to knowledge source when it comes to understanding the bigger picture beyond just the hardware, layer 0, layer 1, PHY layer stuff, all the way up to how that data gets from the PHY layer up into my cell phone and onto my computer. So I'm really excited to have Jason here. Jason, thanks so much for your time.
Hey, Daniel, it's great to be here, and I'm really proud to represent the Ixia group. We were required to help extend and enhance the reach of Keysight kind of beyond the PHY layer and up layers 2 through 7, and we allow organizations that are building network gear to verify that things are working the way they expect them to be working. We also enable organizations that are building and deploying networks to verify that their networks are behaving in the way that they expect them to. And we allow these organizations to have insight into the traffic on those networks, and that's kind of what we call network visibility.
Yeah, so I want to dig into that a little more because I know it's easy for me to get just kind of tunnel vision on the circuit board or the chip or the antenna, but what sort of testing happens beyond the PHY layer?
Yeah, so one of the things that we're seeing in the world of the data center, for example, is that speeds and feeds are always getting faster. So 100 gig, 400 gig, 800 gig. The traffic is always growing. People always want more bandwidth. It used to be streaming HD was fine. Now people want to stream 4K. On and on and on, right? So one of the challenges is that you're building out a data center, and you got to worry about regulatory compliance. You got to worry about privacy. You got to worry about security. And one of the ways that you can handle all of those requirements is through encryption. Now, one of the challenges there is that some of the old approaches to encryption, IP encryption, which used to scale, used to work fine, are now struggling to keep up. And that's caused a lot of the folks who are building and deploying gear to look to a technology called MACsec. And one of the things that MACsec does is it allows you to do encryption in hardware at line rate in high-speed Ethernet. And so that gives you all the security that you want. It gives you privacy, gives you regulatory compliance, all those good things. The challenge is this is relatively new, and if you're building out this gear, you probably want to be able to verify that it works in some way other than you just ship it and see if you get any calls from customers. So we've got a product called Aries One that allows you to verify, test, and validate MACsec on high-speed Ethernet, and we're pretty excited about that.
And especially as 5G rolls out, we've heard a lot from some of our other interviewees how different 5G is from a hardware perspective, but also from a networking perspective and a whole network architecture and infrastructure perspective. It's causing some significant trouble, and people have been prepping as rapidly as they can for it. Can you dig into how 5G is impacting the overall stack?
Yeah, and that's a fantastic topic because it's not only a challenge on the technical level, it's also a challenge business wise. So one of the things that 5G is doing is it's driving an awful lot of new traffic. So you've got folks who have mobile devices, and now suddenly they've got much higher speed connections. So they're going to use those connections and be streaming and downloading and doing whatever they do. But that certainly chews up a lot more bandwidth. Another thing that's happening is you're seeing a lot more of the Internet of Things, the IoT devices. And so you have a combination of the consumers with mobile devices chewing up bandwidth, along with IoT devices creating a large number of data sessions, and suddenly you've got a lot of activity on your network. Now, one of the things that mobile service providers do is they focus very tightly on quality of service. There's two ways they can distinguish themselves. One is price, and the other is quality of service. And you may have heard some slogans like "Can you hear me now?" And various other things. And there have been challenges with folks who have adopted new technology and found their calls were being dropped, or that their data sessions was unreliable, and things like that. These are not things that any service provider wants to see. So they make considerable investments in quality of service monitoring equipment. They've got things called probes on their network that allow them to see what their subscribers are doing, and what's happening with traffic, and what's happening with the quality of calls and data streams and so on. The challenge is that the capacity of those probes is finite. So the more traffic you throw at them, the more sessions you throw at them, the less they have in reserve. And so if you build traffic and you build the number of sessions that you're throwing at them, you got a couple of choices. One is that you can buy some more probes, and they're very, very expensive. The other is that you can use a technology that we have called a network packet broker with what we call the mobile stack software suite. And what this allows you to do is you can correlate the subscriber and data sessions. You can filter. You can basically, in a number of different ways, reduce the load on those probes that you use to monitor the quality of service on your network, and you can do it in a very cost-effective way. So basically, you're retaining the infrastructure that you have, but you're getting more out of it. And you're getting more out of it in a very cost-effective way. And when you have intense competition in the marketplace on price, that's probably a good thing for the mobile service provider.
And these packet brokers are super cool. They're like this, almost like a splitter router for packets, where you can drop it into your network and it doesn't slow things down, but you can still get full access to all the traffic. Is that, and then like analytics?
Yeah. It's so I guess one of the better ways to think of a packet broker is think of it as a fancy switch. And it's a fancy switch that knows how to do some additional tricks. And some of the tricks it can do include encapsulation, decapsulation, filtering, header stripping, and various other things that basically allow you to, I guess you could say, allows you to do more with the analytic tools that you have on your network. Again, just like the subscriber probes, even in an enterprise, things like firewalls or intrusion prevention systems, SIMs, all these things have finite capacity. And the way networks are architected, it's very easy to send duplicate traffic to all of these tools, right? And so that's a problem. Not only is it a problem from the standpoint of just volume of traffic, but it can also create problems with trying to figure out what's happening with various sessions and so on. Some of these tools become confused if you throw them duplicate packets. So a network packet broker, one of the fundamental capacities it has is to deduplicate traffic. So instead of sending 6 copies of the same packet, you send one, and you get this finite capacity on all your tools. You use less of it. You can also do things like let's say that you got a bunch of streaming traffic, And if you're sending this to a firewall, you can probably assume that your Disney movies from Netflix or whatever probably don't need to be closely inspected by your firewall. So you just filter that stuff out. And so this way, you get more out of the existing infrastructure that you have, and you get more effective monitoring, more effective security, and you keep a handle on pricing. Everyone wins.
That makes a ton of sense. Being able to tweak it and see specifically what you're interested in. I imagine that has more applications than just 5G, for example. So where else are we seeing these techniques applied?
Well, so one of the interesting things that's going on right now is there are a bunch of changes happening in the world of finance. Finance has long been heading digital, and one of the changes that's happened is the traditional trading floors. Where you would see, like people wearing funny jackets, waving papers in the air and yelling and doing things like that in order to trade stocks or commodities. The last one of those, the London Metal Exchange, is on its way to shutting down. So it's the end of an era. It's time to bury the dodos. The fossils are going away, and it's all electronic. Okay, well, the whole world of going electronic for finance is kind of an interesting thing, right? So, recently we've seen how the convergence of social media and consumer trading has done some interesting things with a particular stock, GME, GameStop. And there's some interesting things with a short squeeze happening there, which by the time people see this will all have been resolved, I'm assuming. And some people will be fairly wealthy, and some people will be broke, and a lot of people will be entertained in the meantime. But that illustrates some kind of fundamental shifts, right? And one of the fundamental shifts is the importance of the network. I think it was even yesterday, there was a fairly widespread outage of the internet service on the East Coast, and that impacted some of the trading houses. And if you're one of the so-called autists on Wall Street Bets on Reddit, and you're trying to buy some more GME or something, and you can't because the net's down, that's a problem. So one of the things that we've seen is the trading houses have very specialized data needs. There are how can I put this? They have market data feeds that allow them to basically do the transactions that they need to do. Fairness is an important concept, and that involves a lot of time stamping. So you want to make sure that the first order in is the first order that's served. And you've got to be fair about this. So timing is critical. And anytime timing and networking come together, particularly in an IP environment, things get a little bit tricky. And so there is specialized hardware that allows you to verify that everything is healthy with your market data feeds. And we actually provide this hardware to most of the major trading houses in the world, and it allows them to basically understand are things working the way that they're expected to. Are the exchanges and the data that they're dependent upon functioning in the way that they're expected to. And that particular product, TradeVision, has something in common with a lot of the high-speed, high-performance networking gear that high-frequency traders and other kind of financial houses use. And that's FPGAs. Field programmable gate arrays. And that's kind of an interesting flavor of hardware. It's basically like an ASIC. You get ASIC-like performance because remember, there's the old engineering adage, do what you can in hardware, do what you must in software, right? And so having these FPGAs allow you to do some interesting high performance things networking wise, but you still have the ability to reprogram in case a protocol changes or evolves or something, and you're not stuck with basically dead useless silicon, right? FPGAs are not cheap. FPGAs are not easy to program. It takes specialized skills, specialized talent. It's expensive, but expensive and hard, but it's worth it because you get that extra level of performance. And when you're dealing with the world of finance and where things like money matter, it's worth the investment. So that's our product trade vision. And that's kind of how we play into things like some of these interesting events with Wall Street bets and GME and diamond hands to the moon.
Yeah, FPGAs have been a really interesting subject in the last couple of years. We've seen this movement towards open source FPGA tool chains like the RISC-V architecture, and I'm really excited to see where FPGAs go in the next couple of years because they're becoming more and more accessible to small folks with less FPGA experience instead of these big houses like we have here. And the Ixia hardware has some crazy FPGA engineering, so that has been really interesting to look into.
Well, yeah, it's a source of honor. Like a lot of our competition doesn't do that. Either they can't or they've made the decision that they just won't, and that creates some challenges with managing some of the traffic that we're seeing at line rate. So with the Ixia gear, because we do have dedicated hardware acceleration in the form of FPGAs, we don't drop packets. And you can turn on filters, you can turn on features, you can turn on multiple features and filters all at the same time. And the box just churns through the traffic, does it at line rate, and it doesn't drop packets. The whole idea of visibility is you want to see the traffic, you don't want to be dropping packets. If you're doing stuff with security, if you're dropping packets, guess what? You're creating blind spots. And if you create enough blind spots, some of those APTs, the advanced persistent threats, if they're flying low and slow, they're going to get through. And so when you look out at the competitive landscape, it never ceases to amaze us that there are still vendors out there that aren't using FPGAs, that aren't using the right hardware architecture, and they've got network packet brokers, network visibility solutions that actually create blind spots.
Definitely seems like a frog in the boiling water type of situation where it seems fine, but as the line rates go up and as the data rates and the user data flow increases, that would be more and more of a problem.
Well, yeah, it's one of those things that, maybe as you're like initially deploying, everything seems cool. Then you find out, oh, wait a minute, I want to use this feature and this feature at the same time. So, oh, sorry, you can't do that on the same box. Buy another box, daisy chain them. That's something that you see it in data centers, you see it in enterprises, you see it lots of different places. And obviously, if you're the IT guy and you just went out and bought a network visibility solution, you don't want to go to your boss a couple of weeks later and go, hey, by the way, we made a discovery where these new boxes that we got, all the trick features, we can't use them at the same time. We got to buy another rack of stuff and daisy chain. No, that's not going to be a popular answer.
So this all sounds really cool, but for my limited view, it sounds also incredibly complex. How hard is it to get up and running and actually use this stuff?
Well, you actually raise a great point there because ease of use is of critical importance. You can have the very best gear in the world, but if it's difficult to use in the real world, you're not going to get the type of results that you really want to see. One of the things that we've seen out there is there was a large, I guess you could call them like a CDN, a content delivery network, that effectively broke a considerable portion of the internet a couple years back. And the way that this happened is there was a very skilled engineer who was creating a filter using regular expressions, regex. And it's basically like if you do delete star dot star. That star dot star, that's a regular expression, a very simple example of one, right? So he made, I think it was a single character error in a regex expression that was probably a couple hundred characters long. A very sophisticated, very lovingly crafted filter that with one character transposed broke the internet. And that kind of illustrates the importance of ease of use, because regex is a lot of things. It's extremely powerful. It's not user friendly. And one of the things that our software enables is a drag and drop experience. We make things very easy with a GUI. We make things very hard to make mistakes with. Even complicated things like a filter compilation and overlapping filters and stuff like that. It all becomes very easy because it's drag and drop GUI. So these hours of manually tabulating on paper how to do your filters and so on, you don't have to do that. You just drag and drop. And to me, that's actually a very important differentiator, that ease of use. And I think that's something that you see, not only with the network visibility and test gear that we have, but I think you see that across the Keysight line, where everything that we do, we put effort into the software, and we put effort into making the capabilities of that hardware more accessible, easier to use, and more effective out there in the real world.
That makes sense. Yeah, we were talking with Jay Alexander, and he said that 2/3 of the engineering group at Keysight is software engineers. So software is definitely something that matters a lot, even if you have the best hardware. So if people are in,
it's the magic that makes the box go. Software is the magic that makes the box go, right?
For sure. So if people are in enterprise IT or network equipment manufacturers, or they just are curious to learn more, I find this stuff fascinating. Where do people go to keep learning?
Well, yeah, come on down to the Keysight website. We've got interesting stuff in the network visibility area. We've got interesting stuff in the network test area. We'll also be having some cool courses at Keysight University. So, come on down, take a look at what we've got, take some courses, get up to speed on, test and visibility. I think it's a great opportunity. Keysight University is free. There's lots of good learning to be had there, not just about tests, not just about visibility, but other topics too. So come on down and check it out.
Sounds good. And Jason also has been a fairly prolific blogger for the Ixia and Keysight sites. So I think if you Google his name, you'll see a whole list of stuff that he's written up recently. Thank you, Jason, so much for your time and expertise.
Daniel, thank you so much. It's been great to be here.
Thanks, Jason. We really appreciate your time and expertise. And Jason is in the live chat. Every day during this event, we've had some sort of short test gear or application spotlight tip. Since we're already in this part of the technology space, today we have a video that the Keysight Eggplant team put together. Eggplant is a software test automation platform that uses artificial intelligence and analytics to automate test creation and test execution. It can test technology on any device, operating system, or browser, from user interfaces to APIs to databases. It's a really cool approach to GUI testing, among other things. Let's take a quick look at that.
Software is everywhere. In our pockets, at our workstations, in our cars, even on other planets. So when software doesn't behave as intended, things can go from merely inconvenient to catastrophic. That's why it's so important that we find better ways to test software. Eggplant has recently joined the Keysight Technologies family and is designed exactly for this purpose, to rid the world of bad software. Eggplant is trusted to test mission-critical systems at organizations as diverse as the U.S. Army, Walmart, and NASA. To understand what makes Eggplant special, it helps to understand how our approach has disrupted traditional software testing orthodoxy. Traditionally, to test a piece of software, there are manual tests and automated tests. Manual tests are exactly what they sound like, relying on human testers navigating the application in question. Automated tests traditionally involve writing a script that basically tells a program to follow a list of linear instructions. If your software passes the battery of test scripts that you've created, congratulations, your software is perfect, right? If only things were so simple. What if you want to account for user behavior that doesn't follow your exact list of instructions? After all, real people use software and real people have different mental models, preferences, and patterns of behavior. With this in mind, Eggplant bases its software testing product on creating a contextually correct representation of your app, charting all the possible actions a user can take. This model is called a digital twin, which represents the screens, components, and functions in your software. Using the model as a roadmap, Eggplant uses AI to intelligently interpret and navigate your application. Let's see it in action. In Eggplant, we have built a digital twin to test the purchase of a PlayStation through a retailer's mobile app. On the left-hand side, we have our digital twin model. The purple boxes represent the screens in the app, and the smaller gray boxes represent the actions users can take on each of these screens. On the right-hand side, we can see the retailer's mobile app launch. Eggplant uses a combination of computer vision and optical character recognition to interpret the action on screen and intelligently interact with it. Anything that a user can see and do can be tested by Eggplant. This visual approach means that Eggplant can test any system that has a visual interface, regardless of the underlying code. Eggplant just needs access to the same user interface that real people use. Where it gets really interesting is that Eggplant can also intelligently explore a system to identify novel user journeys and uncover bugs that you wouldn't otherwise find through traditional methods. Because this is all handled by AI, you eliminate the tedious manual processes typically associated with exploratory testing. In this way, Eggplant can dramatically increase the test coverage of the system under test. The digital twin can also be used to test your software's performance across different operating systems, browsers, or devices. Eggplant's AI model-based approach means that it is used to test everything from in-car infotainment systems to point-of-sale devices to satellite tracking systems. And as connected devices infiltrate every part of our lives, software will truly be everywhere. We just want to make sure that the software is as good as it can be.
So if that's in your space, there's a link below with more information. Next up, I'm also excited to announce the Keysight Innovation Challenge 2021. This year's event focuses on undergraduate engineering and pre-engineering students enrolled in a historically black college or university to innovate new business opportunities and create videos that demonstrate electronics measurement techniques. We have a short video for that as well. It's like a minute and a half, and then we'll announce today's winners. And now it's time for winners. So hello to everyone who scrubbed through to this point in the video without watching everything else. Go check out the interview. It's really cool, some really cool stuff. So this week's Smart Bench Essentials Challenge winner is Gleb Masny. Congratulations to that. Here's what the judges had to say about their entry, and here is their entry. This is from the judges. We were really inspired by his creative approach to solve his electronics measurement challenges on his bench. For example, using a 3D printer to build a power supply case. He clearly demonstrated his passion for electronics, and we are excited that Keysight Smart Bench Essentials will help him further his research in using genetically modified viruses for cancer therapy and fighting COVID-19. We are confident that Keysight's Smart Bench Essentials is a big step up to his bench and will enable him to focus more on his life-saving research rather than his measurement challenges. So congratulations, that is our Smart Bench Essentials winner. There's a link for that at the bottom of the web page. Let's actually quickly jump to the web page. So we can go back to my screen, and if we go to the other tab, there's a link to enter that. There's one more week, or maybe, I think there's just one more week left of the Smart Bench Essentials Challenge, your chance to sign up for that. Also down here, since we had a DMM video today, make sure to check that one out. It's about 3.5 minutes long, pretty fun video to make. I also apologize for that video. And if you don't know why I'm apologizing, then go watch it. You can also see other days' videos. You can see last week's videos and the whole schedule of events here. And if you want to learn more about using DMMs, there's a DMM Fundamentals of Sensor Measurements Using a DMM Keysight University Live course. This is with Bernard Ang. Bernard is one of our DMM pros here at Keysight. He's a great guy, great course. I've learned a lot about DMMs from him. He's been essential as I get stuck. I reach out to him. So go check out that course if you want to keep learning about DMMs. That's over on Keysight University. You can find that link at the bottom of the page. We're also doing live chat, so get your questions in now. And then get your daily entry. It gets you an extra entry for each day's drawing. There's only one more left after this one. So let's just go ahead and announce today's winners. We have each event day during Keysight University Live, we're giving away to 5 people a Smart Bench Essentials test gear of choice. That's a power supply, DMM, function generator, or oscilloscope. This is the DMM we used in the video from this week and from today, actually. So again, go check out that video if you haven't. Those winners get their pick of a Smart Bench Essentials piece of gear. Eric Hung, Derek Chop, Hendrik Ottman, Josh Gibson, and Atula Vural. So congratulations to those. Those are our Smart Bench Essentials winners. We are also giving away 3 U1282A DMMs each event day. Don't want to drop it like I did in that other video. If you don't know what I'm talking about, go check out our other videos. Those winners, we have 3 of them. That's Romano Agostini, Risto Kempis, and John Matson. Congratulations to those winners. You have won a U1282A. And our first prize winner, they get their choice of a DMM like this, a high-end 3000T series oscilloscope like the one we built a custom label for. It's behind me somewhere over there. Also an electronic load, power supply. There's a whole bunch of different things they can choose from. That winner is Matt Schrader. And I think we've seen Matt here almost every day. So congratulations, Matt. And all of our winners will be in touch with you shortly. And that's it for our main event for today. We are now going to go take some questions from chat. I have chat pulled up here, so I'm just going to pull that up. And the team has also been logging some of those for both Jason and I, and also Jason Lackey's in the chat. So thanks, Jason, for being here. A couple questions. Someone asked about, during the interview, can you fake a timestamp of a packet? And Jason says, it's really hard to fake a timestamp on a trading network. So there's a lot of security technology that goes into trading networks to make sure trades get in at the right time in the right order, because that can literally mean millions of dollars for people. So there's a lot of extra security features built into trading networks. So good question. I wonder how clean a DMM current source would look on an oscilloscope. We can test that out. Why don't we test that out? So in the video today, while I get my scope set up, in the video today, give me just a second. In the video today, we looked at using an oscilloscope as a constant current source. Basically, you put it into resistance mode, you need power. You put the DMM into constant resistance mode, and you can get a constant current out, because that's how a DMM actually measures resistance. is it puts out a known current and measures the voltage across the terminals. So we can actually look at it with the scope. It's pretty clean. I looked at it. I didn't show it in the video because I don't think it added a ton for that bit. It was easier to show it on the other DMM, but we can hook it up with a scope. I need a probe, which I also have handy. How convenient. It's like I planned for this. So what we're going to do is we're going to hook this up to our DMM. Maybe we can pop the close-up camera wider. I don't know. How wide does it go? Let's see. And we're going to put this into resistance measurement mode. And of course, we have to make sure we're in the right ports, which is we are. So we can hook up our probe to our positive, and we're going to hook up our ground to our negative. And there's our current. That's one of the things I like to do when I'm measuring. So first I'm going to go to default setup. One of the things I like to do on a scope when I'm measuring, let's get these cables out of the way. When I'm measuring something slower like this is I'll put it into roll mode, and you can actually watch how it changes over time. So default setup, I'm going to turn off FFT because we don't need FFT. We're in channel 1. There's going to be some noise coupled in because these probes are not great. I mean, the way this is set up is not great. There's a lot of noise in here. So we're in 2-wire measurement mode. We are hooked up the right way. And I would bet almost anything that that's a 60 hertz noise. So we can filter that out. And I'm going to check chat here and make sure we're not missing anything. Okay. So let's see if I can do this from upside down. So for this channel, I'm going to put on a high pass filter. Yeah, DC coupling. Our probe is 10-to-1. Make sure our probe is 10-to-1. That's the thing with the switchable probes. They're really nice to have. They switch 10-to-1, 1-to-1. But if you aren't paying attention, you can get the switch wrong. So just watch out for that. Skew, probe check. Okay. Channel 1 menu, DC coupling. Bandwidth limit, fine, invert. Okay. I'm going to put it in. Let's get a stable trigger would be the next thing to do because we want to see what this noise is. That's pretty stable. And let's drop it into averaging mode just to see what it looks like. So for that, we're going to go to acquire. ACK mode is at normal. We want to go to averaging. And there we can see. So if we capture that and add measurements, so I just hit the measurement button. Yeah, so if we look at our frequency down here, I don't know if you can quite see it on the camera, but 59.8 hertz. So that's just 60 hertz noise from, we have like these power cables coming behind it and stuff. So, and these big studio lights and stuff. It's not a very great environment for low noise measurements. So I wouldn't really worry about the ripple. It's not coming out of that. It's just these long antennas I have hooked up to my DMM. So if we go back to run, then let's pull it out of averaging mode. And instead I'm going to go into high res mode, and that should get rid of some of the noise. And what high res mode versus averaging mode? So averaging mode does every waveform you capture, it averages those together based on how many, basically a number of waveforms per display. High resolution mode does a boxcar averaging, so it averages neighboring points together, which is really good for getting rid of some of that noise that you pick up with stuff like this. So, and again, a scope is really not the best tool for measuring like precision current. If you wanted to get a really high level of precision in your current measurement, something like the 7.5-digit DMM is best, but with an oscilloscope, we can kind of see how it changes over time. You can look at things like AC RMS noise to get an idea of how clean it is, assuming you have a good setup. We're a little on the fly here. If I were to do this in not live mode, we'd do a lot of work to make sure that the environmental noise goes away. But we're not. So let's put it into roll mode. So our time reference center, time mode, normal, there's an XY mode, which is going to look not very good because I only have one probe, and roll mode. So we see that little spike, and I'm kind of curious what that spike is. So if I change my trigger, I can just press the trigger button, and that's going to go, oh yeah, there's no trigger in roll mode. Let's see if we can trigger on that specifically. Okay. yeah, you can really see, the more you do this, you really start to learn that's not my trigger knob, what 60 hertz looks like. Using an oscilloscope upside down is a skill. If you've never done it before, I highly recommend trying it. Let's see. And let's just do a single. Where's my trigger? Down here, single. We're not getting it. Run. Yeah, so I suspect that what's happening, I don't know if this pulses every time it makes a measurement. I don't know quite if it's like continuously constant or if it drops off periodically to do some processing or something. I'm not sure. The DMM is also doing averages of the measurement. So it doesn't make the measurement just one time. It does a series of measurements and then averages them together. And that's where you get if you look on the DMM, we're in slow mode. If we can pull the camera over to the DMM. Right now we're in slow mode. There are different modes. So there's like a fast mode and a normal mode. In fast mode, you end up dealing with the 60 hertz noise. So Dave Jones and I went back and forth on this a little bit as we were releasing this DMM. There's a thing called number of power line cycles where you want your DMM to do so many averages that it basically zeroes out the noise that you get from your power lines. If you go into fast acquisition mode, then if your measurement period is less than 60 hertz, then maybe you're only going to sample during like a positive cycle in your AC power, and that's going to impact your measurements. So if you go into fast mode, it'll get crazy with it. The fancier DMMs have some built-in hardware that do NPLC sensing, and you can actually set the number of power line cycles that you want to average out. The lower cost ones don't have that built in. But again, if you're not going into like super fast, crazy mode, it's not really an issue. Fast mode is more for a manufacturing environment where the number of measurements you're able to make is more important than you're willing to give up some accuracy to make faster measurements. And accuracy meaning power line noise coming in. So so what we can do now is right now we're in auto ranging mode, and I bet that's what's happening on the power supply. What we should have done is you can set manual ranges. So when I go to 100, let's go higher up. Let's go to like 1 mega ohm. Yeah, and because I'm measuring the input of the scope, I should see, there we go. So the oscilloscope has we can see here, a 10 mega ohm input impedance. So oscilloscopes, the input, you don't want your oscilloscope to load your system. So what they do is have a high, at the BNCs, there's a high input resistance, so that when you hook up your probes to your device, that 10 mega ohms in parallel with whatever you're measuring is as close to an open as we can get it and still get good measurements. So when you go to higher end oscilloscopes like the 3000T or the 6000X over there, there's an option for a 50 ohm mode. So we can measure it right now. We're seeing 10 mega ohms. That's the input impedance of this channel. You can also switch some higher end scopes to 50 ohm. And instead of trying to minimize the load on your system, you just design in test points so that you can impedance match at 50 ohms and make better measurements that way, or your probes do 50 ohm measurements. So that's why we had to go up to 10 mega ohm load here, and we're seeing that high resistance. We could probably, let's see, people are talking about my lab. It came off. You know what we could do? Why don't we do this? Let's pull out the big scope, and we can switch this one into 50 ohm mode, and we should be able to see, let me make sure I have all the pieces in place. Yes, we should be able to measure 50 ohm output, and that's actually probably a better way to make this measurement because, we'll be able to see the actual input impedance of the oscilloscope. So remember, that one was 10 mega ohms, and what we're going to do is hook up a little BNC thing here. This is what happens when you ask a question like that. You never know what you're going to get. So let's boot this up. Sorry for my microphone hitting stuff. Unplug this. Unplug that. So what we have here is a BNC cable to this little BNC breakout, and we can hook that up to our scope. It's going to say overload because we're measuring an open circuit right now. There's nothing being measured, so this is well over the resistance range. And if we short it, it won't. Watch this. Boom. And now we're measuring the resistance of our leads, and we could null that out even if we wanted, but that might be too much. Oh, this scope has a label on the back that says broken. This is just a set piece. There's another one back here I can use. Okay. I forgot about that. I sent my other scope to Ben Eater for a USB video. So Ben, if you're watching, I need my 4000X back. No, I'm just kidding. If you haven't seen Ben Eater's YouTube channel, he does some fantastic stuff on breadboards. So he's probably I don't know if he's like the world expert on breadboards, but he's done like video cards and full PC builds on breadboards. It's amazing. So go check out that channel. That fan is a little loud to boot up. This is a 6 gigahertz 6000X series oscilloscope. So this is actually one of the grand prizes. So next week we're giving away a scope just like this. It's the same user interface as all the other Infinivision oscilloscopes, but this one goes up to 6 gigahertz and it has lower noise. So the front end is different than like the 4000 and the 3000. So this is probably a better one to actually measure the cleanliness of the current output for this because the front end is a lot cleaner. So let's see, we got more talking about the microphone. Let's see if I'm messing anything up here. It looks okay. NPLC, yeah, it's an integer. It doesn't have to be an integer. It can be like 1.5, but it's better for it to be an integer because then you're integrating over a full cycle. So that is good. Someone says, go get a coffee. Ha, hilarious. Let's see, other questions while this gets going. Okay, here we go. These actually, I think this is the fastest booting 6 gigahertz oscilloscope on the market. So I love this. The scope is so great. If you want to get high bandwidth measurements and you don't want to go through the whole Windows thing, you just want like quick lab measurements, it's a fantastic scope. It also does some like jitter analysis packages and like color graded FFTs and eye diagrams and all kinds of fun stuff on this. We have videos on the Keysight Labs YouTube channel more about jitter. So if you search for jitter on our channel, you'll see some videos that highlight the analyzing jitter and what you can learn from jitter analysis using the scope. It's pretty cool. Okay, so now we're seeing a 1 mega ohm input impedance, which is about what I'd expect. And then if I go to my channel 1 menu, and so you can see down here, our impedance is set to 1 mega ohm. I know it's kind of hard to see on the camera, sorry about that. But there's a 50 ohm mode, and it's gonna warn me when I go into 50 ohm mode. It says, hey, watch out, because it's really easy to blow up your inputs on 50 ohm mode. So in 1 mega ohm impedance mode, there's a separate signal channel path there's like a 50 ohm path and a 1 mega ohm path, and I talked about this a little bit in the how to use an oscilloscope video. The 50 ohm path has a lot less input protection than the 1 mega ohm path because we assume you're going to be much more careful with your 50 ohm path. So we're in 50 ohms, and when I switch to that, I hit OK. And this should switch, because we're in the 1 mega ohm range, or the 10 mega ohm range measurement, it's not going to show that. But if I go to the 100 ohm measurement range on my DMM, we now see just about 50 ohms. So there's the difference. You can actually see the difference in input impedances of your scope. That's what's happening at the channel, output channel of your oscilloscope. And now we want to measure current. Again, this is not an ideal current measurement setup, especially like precision current measurement, but hey, why not? Let's give it a go. So I'm going to again hit default setup, and I'm going to go to my channel 1 menu. Can't really see it from here. And if I zoom in, that's my time. So I'm measuring voltage. So what I probably should do is like put a shunt resistor out, but that's what this is doing. So I went back to 1 meg. There we go. Oops. When I hit default setup, it put me back to 1 mega ohm. That's another safety protection feature is you don't want to accidentally have your scope in 50 ohms. You want it to default to 1 mega ohm, so default setup, reset that. And now we see it on our DMM again, we're at 50 ohms. And if I go to measure this, okay. So I'm going to zoom in about as far as I can on this. And again, it's going to be noisy because you can see the noise in here. That's all this. And when I move it, I think I probably need to boost my intensity too. There we go. So, a lot of this noise is just the probing setup. If I wanted to do this really well, I'd get a nice fancy probe. I'm not going to run down the hall and do that right now. But the probe and the scope combo is where your noise mix comes from. So you have to check your noise budget and make sure you're able to see what you need to see. So if I go to measure current, you can pretty much just see the cleanliness of this. And as I get closer, I can actually change this. But as I change ranges, we should be able to see a shift in current levels. So I can make this even bigger. And again, this is a lot of this noise is the probing setup. So as I change the ranges on my DMM, if we can get both of those in shot. As I change the range of my DMM, you can see it shifting through the different ones there. It'll actually adjust the current level. So let's start at the top. Oops. So there we go. So that's 100 ohm. So at 100 ohm resistance measurement range, we're going to output a higher current on our DMM, and we see that here. And the reason it does this, is I mentioned this in today's video as well, is the goal of the DMM, just like the oscilloscope in high impedance mode, is to minimize the impact of the measurement on your device. You don't want to put in 10 milliamps or like an amp of current from your DMM because that's going to affect what you're testing. So as you change your resistance measurement ranges on your DMM, the current output is actually going to drop because you're assuming a higher voltage. So, Ohm's law, V equals IR. If we're assuming the R is high, we want to make sure the I is low so that the overall impact to the V is lower and the power is lower. So that was a long answer to a short question. But I love doing this sort of thing. So if you have more questions, keep them rolling. We also set up a Twitch channel. We're going to do some Twitch streaming periodically throughout the summer. We actually had a stream about a week ago, so shout out if you were there. We had a great old time. I got a couple boxes in my cube, and we pulled those out and played with DMMs a bit. So that was fun. We may even do some like behind the scenes making of our videos and stuff on the Twitch channel. So go check that out. It's Keysight Labs on Twitch. If you do Twitch, if you don't, no big deal. But that was a ton of fun, unscripted. Just kind of figured it out. So go check that out. There's nothing recorded because we're new to Twitch and figuring out. I'm new to Twitch. I did it all on my own. So if I had brought in my video guy, it would have been a lot better. But it was good. We had a good time. Other questions? Is Eggplant a standalone software or on cloud online? It is standalone. I think there are cloud components to it. One of the things I believe they can do is also they can take robot arms and do like physical button presses. So I'm really gunning to get a robot arm, and we can play with that software a little bit. Yeah, someone says you're trying to measure the wrong thing. You want to measure with a current probe. I do want to measure. I should have measured this with a current probe. I don't have one in line here, but essentially what we're measuring is that input impedance shunt resistor on the input of the scope. So you don't necessarily see quite how clean the current is, but you can infer from the voltage what it looks like. So to super Numex, you are totally right. If I had a current probe, that would be a much, much, much better way to do it. And someone asked, I think these questions are a bit old. There were some spikes we saw. I think that was the auto-ranging, because we were in auto-ranging resistance measurement mode. The current was essentially resetting as it cycled back around. Other question. Did I plan to do live demos today? I didn't really plan to do live demos, but we have all the gear here and we're live, so we might as well do live demos. Are there 50 ohm attenuators built into the scopes? So you want to check your scope and make sure it does have 50 ohm mode if you want to use it. That's also normally where they spec noise levels. So if you look industry-wide, regardless of Keysight or someone else, the noise level of a scope that has 50 ohm mode is going to be spec'd in 50 ohms. And the reason you have to go to 50 ohm mode is as you get to higher frequencies, so around like a gigahertz or gigahertz and a half of bandwidth, The noise, you just can't really keep measure. Like there's some technical requirements in the front end and just in the measurements where having high impedance becomes unfeasible and you have to switch over to 50 ohm mode. So when you get into those like 2, 4, 6, 10, 30 gigahertz measurements, you have to switch to 50 ohm. And that impedance matching to your board and to your device under test or your DET becomes very, very important. So good questions. What else? Someone says I need more toys. Yeah. The lav we're using is a Rode. I don't remember the name of it. It's the Rode mic pack. It works okay. Lots of talks about robots. What else? Walt Perko's talking about his stuff. Go check those out. RoboTunes. Looks interesting. I'll check that out after the stream. And that's about it. I think we're going to call it a day. Again, if you want more live demos, we'll do a little bit next week. Next week is the last day of Keysight University Live. So we're giving away a ton of gear. I think we're giving away like 15 or 20 prizes next week. So make sure you get your entry. I'm really excited. Come in swinging with questions. We'll do a little bit of Q&A, but we try to chop it short fairly early on the last day. We have some fun interviews next week as well. So again, tune in. Thank you so much for being here. If you've stuck around to this point in the stream, my sincere appreciation for you and thank you for your time. And I'm Daniel Bogdanoff, live from Colorado Springs, and I'll see you next week.